Hello everyone, it's NetMaven. Today we're gonna make a lab about NDFC for classic LAN deployment lab. Think about this company, Pursuit.co. Pursuit.co is updating its IT strategy with the goal of creating a unified data and security approach that works across all of its business units within the next 3 years. So to support this, the company needs a simpler and a more automated way to manage its Ethernet-based networks using a SDN software-defined network for the day 0, day 1, and day 2 operations. In London data center, say in here, this London data center, Pursuit.co currently has a Cisco Next network building the three-tier classic LAN design using Nexus 9000 switches, all configured manually through CLI. As part of the modernization effort, this Pursuit.co plans to upgrade these data center fabrics by introducing NDFC Fabric Nexus Dashboard Fabric Controller. NDFC will take over management of the existing London Brownfield fabric that will also help streamline the deployment of the new Greenfield fabric that will be used to expand capacity. In this lab, I will use NDFC to bring the current Brownfield enhanced classic LAN fabric under management, build and deploy a Greenfield enhanced classic LAN fabric and configure the layer 2 and layer 3 settings such as VPC, such as VRFs, and the network for new fabric. I will also create and deploy a new external core fabric and extend VRFs from both classic LAN fabrics to external core to support the communication between the fabrics and with the external network. So what is the NDFC? Cisco Nexus Dashboard Fabric Controller is a network management system designed to manage both LAN and SAN fabrics from single interface. So it works across all Cisco Nexus and MDS switch families and can manage large numbers of devices. We're just providing a building, automation, and control features, including VXLAN for Nexus LAN fabrics. It also supports automatic configuration for multi-tenant environment, provides a integrated storage visibility and provisioning. It offers clear topology views for both LAN and storage fabrics. All right, this is the short introduction. Let's get our hands dirty by first review the existing Brownfield configuration. We're going to log in access 1 and access 2. Logging should be done automatically. Let's explore L2 configuration on the access switches. We'll access interface 1/5 on each switch, they're connected to server 1 and server 2, uplink to upgrade switches, aggregation switches, interface port channel 1 and the VRF configuration and the status. Then we're going to log in the aggregation 1, aggregation 2, and the logging should be automatically. Then we could explore the L2, L3 on aggregation switches, the downlink to the access switches, port channel 1, and the VPC configuration and status, VRF, subnet, and the routing table. So via server 1 and server 2, subnets are located in your VRF with name pseudocode VRF1. The routing between these subnets is done on pair of the aggregation switches configured with HSRP already. So we'll show run interface port 1, channel 1, and show run VPC, show VPC, yeah, up and success, show IP interface with VRF all, show IP routes, VRF will have pseudocode, VRF1, so we could log into the aggregation switch, and we're going to show run interface port channel 1, show run VPC, show VPC, show IP interface with VRF all. Then we should see all the VRFs and show IP routes, VRF per pseudocode, VRF1. Next, we're going to verify server's IP configuration and connectivity. So we are going to log in server 1, 2, and 3. IP config, we shall see the Ethernet 1 is configured with IP for server 1, IP config for server 2, server 3, IP config, IF config. So now to verify the connectivity, we're going to from server 1 and ping the server 2 IP 10.10.2.20 is server 2 and ping is okay. And we'll ping server 3 10.10.3.30 is not okay. Then we'll ping 101.1 is representing an external source. So we see that the ping is successful only to 10.10.2.20 server 2, which is connected to another access switch in the same Brownfield fabric. This means that the Brownfield fabric is configured with an operational. The Greenfield and external fabrics are not configured, so ping to 10.10.3.30, the server 3 and 101.1 external resource are not successful, and there's a 100% packet loss. Now, what we want is to import and deploy a Brownfield fabric into NDFC. We imported the Brownfield fabric into NDFC, and I will verify the ping between the servers after fabrics was imported to confirm the fabric is still functioning as expected. Let's log into my NDFC. On the top, we're going to select Nexus Dashboard Fabric Controller. Let's click LAN and Fabrics. Take action to create a fabric. In the fabric name field, we want to say that's Brownfield fabric. We want to pick a fabric, say Enhanced Classic LAN. In the general parameter tab, in the BGP ASN field, take a 625.0.0.1 And I can click configuration parameters in other tabs like spanning tree, like VTP, etc. So for this lab scenario, there's no need to change it. We'll leave default values. In the configuration backup tab, let's check hourly fabric backup. Then we can click save. Double click this Brownfield fabric name and I create to show the fabric details. In the fabric switches, let's add the switch, the seed IP, and you want to take password, username, uncheck this preserved configure toggle. You want it, okay, actually you want to check it because it's a brownfield. Think about it and click discover switches. So I want to check boxes for Brownfield fabric switches, access 1, access 2, agree 1, aggregation 2, and click add a switch. When the import completes, let's close. To display the list of the onboarded switch, let's click the switches again, and we're going to track the box next to agree 1, agree 2, and we'll set the role. The role will be aggregation. Click select. When the recalculate configuration warning shows, let's click OK. In the Fabric Overview window, click this action and recalculate the deploy. The recalculating and the configuration tasks take some time. NDFC will read the configuration from switches and compare it to the fabric configuration. In this lab, there's no configuration differences, or it might be minimum. Current switches configuration matches fabric configuration on NDFC, and NDFC does not change the existing configuration parameters. Optionally, we can click pending configuration and check the pending configuration. So if presented, we do a side-by-side comparison. Is the current config and the expected config. So right now, just let it recalculate that. Should be soon. I pause my video till it's complete. Let's close the purview configuration. Well, notice the switches list configuration status is in sync and the mode is the normal. Then check configure imported configuration. The doing Brownfield fabric configuration synchronization. NDFC imports all of the existing configuration from switches, including VRF networks and VLANs, port configuration, etc. Let's click networks and let's click VRFs to see the list of important networks and the VRFs. Let's close the fabric view overview and we'll click topology. Then in the display, we'll click this BF fabric and then click the configuration. If the layout is different from what expected, we could drag in the switch to match the layout. All right, it is what I want. Let's confirm still the server 1 ping server 2. On server 1, ping 10.10.2.20. Ping is successful, meaning that the configuration was preserved and the fabric is operational after import to NDFC. Now it comes down to the task that we will create and configure the Greenfield fabric. Go to NDFC, we'll go to LAN, and we'll take fabrics, and we'll create a fabric. In the fabric name, say it's Greenfield fabric. We'll pick Enhanced Classic LAN. In the General Parameters tab, in the EGPS number, we'll enter 65002. In the Advanced tab, we're going to scroll down to what we call Greenfield Cleanup option. We'll drop down to Enable. To avoid overlapping with Brownfield fabric, in the Resources tab, scroll down, we want to find is the IPv4, VRF Lite subnet IP range. Let's change this to say 60. Change to 35, 10.35.0/16, and go to IPv6, change to 2001:10:35:00/112. Okay, and you can check configuration parameters in other tabs like spanning tree, VPC, etc. Well, I'll leave this default values. In the configuration backup, and we will want to take the Huawei fabric backup and save. All right, going to Greenfield fabric, go to switches, and we'll import my Greenfield switch. Enter the username, password. Uncheck this preserve configuration toggle because we are creating a Greenfield fabric. Click discover switches. Now we wanted to check, say, access 1, access 2, aggregation 1, aggregation 2. Because I enter wrong seed switch, so it still gives the Brownfield. So that's not what I want. Let me enter a different seed switch and username, password. Let's take this step again, check the warning. Now, I have access 3, 4, 5, aggregation 3, aggregation 4 switches. So I check those switches 3, 4, 5, aggregation 3 and 4, and click add a switch. When import completes, let's close it. Again, check aggregation 3 and 4, and we set role to aggregation switch. Click OK. Now, In switch 3, check it, and will tell you what to do. Click Action. We're creating a VPC pairing. It's pairing with aggregation 4, and click Save. Click OK. In the Fabric Overview window, let's click Action, recalculate and deploy. Again, they will take some time. For Greenfield Fabric, the pending configuration is larger because NDFC will clean all existing switches configuration and apply new configuration according to fabric settings on NDFC. Of course, optionally, you can click pending configuration and check pending configuration and do the side-by-side comparison. The current config versus expected configuration. Now, here you go. We'll just briefly look at it. Now, click Deploy All. When deployment completes, click Close. We notice that in all switches, configuration status is in sync. Mode is normal. Let's close this overview. Click Topology. What click is the Greenfield Fabric and click Configuration. Now on server 3, we're gonna execute route command. We'll ping the next hop. The route ping 10.10.3.1. Ping is not successful, meaning the next hop is not reachable or does not exist. We'll configure the fabric, access interface, and VRFs subnet for server 3. So go to LAN, Fabrics, Greenfield Fabric, in the Fabric overview here, click Interface. We're gonna check box next to Access 3 Ethernet 1/5, this interface. And action is added in the policy list. We're gonna pick interface access host and the save. Here we see the deploy button is becoming active and deploy now. Should be active right now and deploy config. Now then create VRF. Let's create a VRF. Let's say per sudoku VRF1. We'll leave everything default and create. And then go to networks. We're going to create a network. For sudoku nest3. And this is my VRF we just created. VLAN ID, click propose VLAN, say 3300, gateway 10.10.3.1, query that. Interface IPv4 address on active 10.10.3.2. Standby 10.10.3.3. After create a network, click create. We're going to click this and here multi-attach. We want to select VPC. First the VPC here, and here you go. Well, next to VPC pair of the aggregation switch, and I'm going to find interface. Let's select let only access port with 1/5. Select OK. Now, next. Save. Here are all the pending configurations. Report. Click close. Now, take a look. Server 3. Ping is successful. Route ping again is successful. Okay. There's a first video, then stay tuned. Next step, we'll create and configure the external core fabric. Stay tuned. See you next time.
Hey everyone, NetMaven here. Don't forget to hit that subscribe button to dive into the world of amazing network technologies with me, and please feel free to leave your comments below. Hey everyone, NetMaven here. Don't forget to hit that subscribe button to dive into the world of amazing network technologies with me, and please feel free to leave your comments below.